Hello guys, I'm audible. So, what we have discussed in our last class, I think any one of you can please tell what we have discussed. So, all of you have tried this particular problem or not? What is the answer you got for this particular problem? Any one of you? What is the answer? 43 divided by 3 by 3i. Let me check it out. Seems to be correct. Just wait a moment. I need to check the answer. So, all of you are getting the answer as third one. Yes. So 43 by 3i, that is the correct answer, right? 43 divided by 3i, that is the correct answer. Now just note down this particular problem that they have asked in GATE 2018 in aerospace. This particular problem they have asked. Now, so how to proceed with this particular type of problem? Let's see. Statically indeterminate beam, right? These are the statically indeterminate beams. Statically indeterminate beams. These are the statically indeterminate beams. Now, in this particular problem, my different a clamp beam, that is a cantilever beam, subjected to a point load P exactly at the middle. So, For some extent, this statically indeterminate problem looks easy because of symmetricity nature, right? It is looking very easy now because of symmetric nature of the loading conditions. Magnitude of the moment reactions at the two fixed end they are asking. So see, we can solve this particular problem by two manners. I'll be telling you both the methods. Please make a note of it, note down the diagrams, and put the heading statically indeterminate. This, what is the meaning of statically indeterminate? Number of reactions, number of unknowns will be more than number of equations. Number of static equilibrium equations. So how many reactions will be coming first of all? So there will be reaction force here at A, at B, at C. There will be some horizontal reaction force will be there at a point. There will be some movement also at a point. Here also there will be some movement at B point. There will be some reaction force, you know, at C point. So let me call this to be C, RC, and there will be some horizontal reaction also. But here there is a no horizontal force, so both these particular force will be zero. RAH A and RSC will be zero. So what are the next tasks we have to do? The next thing that we have to calculate is bending moment. We have to calculate the moment reactions, right? And we have to calculate the support reactions, vertical reactions. So for the symmetric loading, you know that for symmetric loading, we know that RA is equal to what? RA, RC, and moment at A point will be equal to what? Moment at C point. Because of symmetric nature of the loading conditions, moment at both the ends, that is a reaction moment. Remember, these are the reaction moment. These are the reaction moments. This reaction moment will be same. And whatever the vertical reaction force will be there, that reaction force will also be same, right? Make a note of it. We can solve this particular problem by moment area method, and we can also solve this particular problem by principle of superpositions, right? So we have flexibility to use any method and we can get the answer. All of you are getting my point or not? Tell me guys, all of you are understanding? Till now, whatever we have covered in the strength of material, one by one, you are getting the particular idea or not about the subject? Tell me guys, understanding? Correct. So here by different, just to make a note of it, then we can see this particular problem. Let me add this slide. All of you might have noted down the problem. Let me solve it. Try understanding, guys, how we can proceed with that. See, very first thing is that this is a reactions R, and this is the movement M, right? And there will be some point load which are acting exactly at the center, you know. And let me call this to be A point, B point, and C point. For example, let me just see. Yes, A, B, C I have considered. So A, B, C. Let me consider the same points. Here you try to understand what I want to say. Moment area method. By moment area method, we know that if I draw the elastic curve, if I draw the elastic curve, it will be something like this. If I draw the elastic curve, it will be something like this. So what is the boundary conditions? My different boundary condition we can have. What is the boundary conditions we can have? Boundary condition we can have, my different, theta A will be 0, theta C will be 0, theta B will be 0, deflection at A, deflection at A will be 0, deflection at C will be 0. So we have the five boundary conditions, right? We have, my dear friend, as you can see very clearly, we have the five boundary conditions, but those five boundary conditions are useless for us at this point of time. You can solve the particular problem by all the boundary conditions, by solving, by basically having the double integration method, framing the equation for this particular bending. You can get the answer by this particular boundary condition, but we are not going to use that one because that is going to be very, very lengthy, right? So why do you make this particular simple problem very lengthy when we know the solution for that, right? And what is the solution, my dear friend? We have the solution called moment area method. And see, by looking at this figure of curvature, what we can say, that what is the theta c with respect to a, that is going to be 0. Everyone agree with me? The final theta c with respect to a, c, has to be 0 because theta c minus theta a, that is theta c with respect to a, theta is 0, theta c is 0 because that is a fixed support, and because of the fixed support, that is going to be 0. So theta c with respect to a automatically will be 0. And according to moment area method, the area of m by ei diagram between c and a has to be 0. Area of m by ei diagram between c and a has to be 0. Sir, what is the m by ei diagram? That you can make by principle of superpositions. What you can consider? You can consider first, what you can consider, my friend? You can consider this particular structure to be made up of two things. One is a simply supported beam. One is a simply supported beam which is supported like this, and which is being subjected to a point load, plus it is being subjected to some kind of movement at the ends. Finally, the picture is same, check it out. If I combine together these two things, I will be getting this particular picture or not? The final bending, final particular beam which we are having. Please check it out. Getting my point? Tell me, guys. What happened, guys? Understanding or not? Please. If any one of you in the class, if you're replying, then it will be fine because I know that sometimes you might be focusing on the particular topic, so it's very difficult to reply in between. But that is actually my habit of asking in between. So theta c with respect to a is 0. And according to theorem number 1, this is what theory number 1. Read the statement of the theory number 1, my dear friend. If I just take you back to the particular theory number 1, what we have, my dear friend? Theory number 1. Observe very carefully. The angle of tangent between any 2 points on the elastic curve will be equal to what? Area of under what? Area under the m by ei diagram. Angle of tangent between these 2 points. And if the angle of tangent will become 0, angle of tangent between these 2 points. Draw the tangent, my dear friend, at both the points. At C points, A point, that will become a horizontal line. And angle of tangent, there's no tangent, 0 tangent is there. If that is 0, you know theta c, if I'm measuring, suppose theta c with respect to a, that is equal to 0, that means what? We are measuring with respect to what? With respect to tangent drawn from other point. This is the tangent at a, this is the tangent at c. Both are 0 itself. M by ei diagram will also be 0. Getting my point? Tell me, guys. Now, my dear friend, we have to just make use of two things. That is, our first is nothing but the simply supported beam, plus there will be some external moment. Now, because of this simply supported beam, my dear friend, because of this simply supported beam, what will be the bending moment? The bending moment will be like this. Perfect. And my dear friend, what is the basically the load? L by 2, L by 2. So everybody know that this will be the bending moment, PL by 4. Getting my point? PL divided by 4EI. That will be the M by EI diagram between A and C. because of this loading conditions. And because of this loading condition, my different, this will be the bending moment diagram. M minus M into L. That will be the negative. Combined together, area of M by EI diagram between A and C because of the first loading conditions plus because of the second loading condition has to be 0. Right? So what is the area of M by EI diagram between C to A from here to here for this particular sections? So half of PL divided by 4EI, half of PL divided by 4EI into what? L by 2 into 2 minus of this particular area. This is a positive. This is a positive area. What is the negative area? M divided by EI into what? L. That has to be 0. Ultimately, total area has to be 0. Then from here, what we are getting by different? ML divided by EI, that is equal to what? PL square divided by 8EI. So this will cancel out. What is the M value? PL divided by 8. So when you look at the options, what we have? PL divided by 8 will be the correct answer. Please check it out. We are making use of, for drawing M by EI diagram, we are making use of principle of superpositions. That is, we can assume that this is made up of two beams. One is a simply supported beam plus other is what? This type of beam where end moments has been applied. And both are resembling the same thing. At the ends we have the reactions and we have the moment also. So they are basically the replica of the same beam. All of you are getting my point? Any difficulties? Tell me, guys. Yes, correct. So that is the first method, my dear friend. You can get that particular value of M is equal to PL by 8. And everybody know that in the class, they can very comfortably, they can tell me that what is the reaction force? P by 2. Right? Because of the symmetric loading condition, there is no other loads. So while doing so that, we can get the answer for R is what? P by 2. How, sir? Summation of moment about any point to be 0. If I take summation of moment about any point, about 8 point to be 0, the net moment, including the reaction moment, so what I will be getting, my different, I will be getting, suppose M is there, right? This M and this M will cancel out. So ultimately what we have? R into L minus P into L by 2, that is equal to 0. So R is what? P by 2. So RA is equal to what? RC, that is equal to what? P by 2. Make a note of it. Getting my point? Now some of you might be confused, sir, in the summation of moment, why you are not taking the moment this one? See, you can write plus M, this plus M. See, if you are writing minus M, so for example clockwise you are taking negative, minus M plus this one is also acting, that is a clock anti-clockwise. So plus M minus M plus M, that will be cancelled out. So whether you write or not, doesn't matter actually. They will be cancelling out, and ultimately we are getting what? R is equal to P by 2. Right? Make a note of it. Is it done? All of you have noted down, my different. Tell me, guys, is it done? Correct. So my different, why I'll be telling you the second method, see, I invest a lot of time in doing the research in solving the problem in so many ways, So the idea behind that, not to waste the time actually. The idea behind that particular research is to solve the typical problem, in a very easy manner. Suppose in exam, every time you won't get the very simple problem, in gate. Suppose for example, the in gate examination, the question has been given something like this. First, let me basically tell you the motivation why we are using the second method. If you have motivation, then we can, actually we can just listen very carefully and with so much of enthusiasm. Let's suppose this is the cantilever and this is the P. This is basically the load distance is what we can say L by 3. This is 2L by 3. In this scenario, my dear friend, it's very difficult to get the idea, by simple method. If there is an unsymmetric nature of the conditions, then it is very difficult, right? We can get the movement very comfortably, but if they will be asking you some other things, then it will be a very challenging one. Or maybe if it is combined with some other kind of loading condition, something like this. Of course, they will not ask that much deep, but in gate examination, you can never expect. Before 2018, nobody, basically in aerospace industry, nobody have ever thought that basically to have this discussion on this statically indeterminate. Of course, we have the discussion. They might be having the discussion also, but they never thought that they will be asking the question from that statically indeterminate beam. But they ask the question. So anytime in gate exam, anything can be asked. So for that particular purpose only, I'm just telling you the second method. If you are liking, you can take it out. Otherwise, you can just happy with the what we have discussed. Again, this is basically the whatever the conclusion I'm drawing. That is, I'm drawing based on the principle of superpositions. P L by 2 L by 2. My dear friend, I can just make it this particular diagram something like this. Equivalent diagram I can make something like this. There is a support at C point, and there is some kind of movement, my dear friend. There is a support and there is some kind of movement that is being applied, right? Some kind of movement that is being applied. Let's suppose this particular reaction is R, which is same exactly as R, and there is a movement M, right? And of course, we have the load P also at a distance L by 2, L by 2. So I can make this particular figure like this. So now everybody know that we are making use of next compatibility equation. What is that compatibility equations? Deflection at C, the net deflection at C has to be 0. Ultimately net deflection is getting 0. If you draw the diagram, elastic curve, we are getting what? 0 deflection. This net deflection we are getting for basically from three particular segment. One will be P will be applied here. What will be the basically, what will be the basically the deflection at C? I'm calling this to be delta C1. That is the first scenario. Second scenario, my friend, I can just make use of what? Something like this, where we are applying the bending moment M. And in this scenario, if I add, I will be getting what? Again, the bending, basically what? Deflection delta C2 at the point C. But we are going to get the value because of this R in the upward directions kind of things. This is delta C3. Overall, delta C1 plus delta C2 minus delta C3 will give me the net deflection at where? At C point. That has to be 0. Principle of superpositions. We are making use of superposition principle. Superposition principle. And by the principle of superpositions, we are going to get this particular scenario, a big picture over the here. Delta C1, everybody know that what is the answer? L by 2, L by 2. So this is nothing but B, this is C. So ultimately, elastic curve will be same. So slope at B point for this line will also be same. So this is theta B. So delta C1 will be delta B plus theta B into L by 2. So delta B will be what? P into L by 2 whole square divided by 2EI. Plus, I think I already discussed this particular part, delta C1. P into L by 2 whole square divided by 2EI into L by 2. If I just calculate, I'll be getting what? 5PL cube divided by 48 EI. So this is delta C1. What is delta C2, my dear friend? Delta C2 will be ml square divided by 2 EI. And what is delta C3? RL cube divided by 3 EI. Overall combined together, when you club together all the things, delta C3, we know that R is what? P by 2. P by 2. So when you put P by 2, so I'll be getting what? PLQ divided by 6EI. So ultimately, if I put delta net deflection to be 0 at C point, then what I'll be getting my difference? 5PLQ divided by 48EI plus ML square divided by 2EI minus PLQ divided by 6EI. That is equal to 0. So I'll be getting what? MS PLQ divided by 6EI minus ML square divided by 2EI. That is equal to, so M divided by 2 PL divided by 6 minus 5PL divided by 48. M will be what? 48 will be common. 2PL into 2. No, this will be 3. This will be 3. So 24, this will be 8. So once again, I'm getting what? M is equal to PL divided by 8. Please check it out. So this is our second method. With the help of that, you can get the answer. Once again, you can get the answer for R also. Suppose somebody might be interesting, sir, I don't know whether it is P by 2 or not. How can I predict that? Even though it is a symmetric loading condition, I don't care. I need to just know, basically I need to see exactly how we are getting R is equal to P by 2. For that, you can do as a homework, theta C net will be equal to 0. If you do that one, you will be getting one equation, and you will be getting here as second equation. Don't put R is equal to P by 2. You just put whatever the delta C3 is there, you just put in terms of R only. You will be getting first equation here, and you will be getting second equation over here. Solve those two equations, you will be getting M as well as R. M value will be PL by 8, R will be what? P by 2, right? For everything we have the solution, my different. No need to get panic. Why it is P by 2? Why not it is something like that? Getting my point? All of your understanding? But try to develop some aptitude so that in GATE exam, they will be testing you, not the patience with the questions, not with the struggle with the questions. They will be testing you. They will be testing the how quickly you are able to apply the logic behind that question. That's it. In a very simple word, what is the GATE exam? How quickly you are able to apply the logic. That's it. If I just throw the new question in front of you, if you are getting the logic, that's enough. You are definitely made for getting the good rank in GATE exam. But if suppose somebody who are not able to apply the logic, no need to get panic. You just work hard, keep working hard, keep working hard. The logic will be automatically applied. You will be surprised to see how I got this particular good rank. I'm telling you frankly. But don't give up. In any topic, don't give up. So this topic is paining like anything. I'm not able to get the good solution for that. Even though I'm getting the question and solution after seeing the solutions. No need to get panic. Work hard. You will be getting the basically success behind that particular chapter like anything. For that particular chapter, if you keep on working hard, definitely you will be getting the idea behind that chapter. Right? Once it is done, let me know. But without putting some effort, you completely dependent on me or some other faculty, that if faculty will be telling me, then the subject will be easy, or I will be start working regarding some more problem, then definitely you are in the wrong path, on the wrong path. Right? I can solve n number of problem, but there is no use of that. That will be practice for myself only. More than that, nothing can be happen. You can satisfy, you can be happy for basically 2 hours on whatever the discussion is happening, but that is nothing but just like a very, every question is like a spoon feeding. Ultimately it will kill your aptitude, skill. So try to develop habit of that. you know is it done? Can I move to the next one? Now, so try understanding, my friend. The next particular segment what we have to discuss is Castiglione's theorem. Castiglione's theorem, yes, no doubt. In the last particular first chapter, we have discussed that strain energy due to axial loading. Here we are coming over here. We have to discuss about the strain energy because of bending. Because you know that when we apply the loading condition, definitely the body will stretch out. When the body will be doing some stretch out, when the body will be doing some stretching, some work has been done. If the some work has been done, energy is conservative. Energy cannot be go anywhere by the thermodynamics law. By the thermodynamic first law, what we can have, energy cannot be created, not can be, it cannot be destroyed. It can be converted from one form to other form. So whatever the work done you are doing, this external movement you are applying, that will be stored into some other form of the energy, and that form of energy will be welcome in the strength of material, and that is known as strain energy. No doubt, strain energy. And strain energy, because of the bending, we already seen the formula, my different. What is the formula? Mxx whole square dx divided by 2ei. Just turn your pages like anything, and you can see that the beautiful formula, where ei is nothing but flexural rigidity. Remember, flexural means bending only. Flexural rigidity. Flexural rigidity, very very important. Total strain energy will be something like this for this particular beam A to B. If I need to find what is the strain energy for this beam shown in the figure, then we have to calculate the what is the bending moment which are acting at this particular section. Castiglione's theorem is basically known as strain energy method. Then all of you have noted down. Is it done for all? Now try understanding, my friend. Note on the Castiglione's theorem. I don't know, guys, whether you are understanding strength of material or not, because I'm not getting proper response. Actually, I'm frankly telling you. I can see that only 5 to 6 guys who are responding, and they are actually solving the homework problem, but remaining guys, I don't know. I don't know why the response is not there. Whether you are actually not liking this particular subject or the way of teaching, I don't understand actually. Or maybe you are just, uh, you know, so lazy enough to reply in the particular chat section. If that third case is there, then I can understand. Tell me, guys, getting this subject or not? Correct. Now, see, it's actually you can correlate my and basically my situation with yourself. Suppose you are two-person is there, you yourself, and some other person is there, and you are explaining something to him. You can try this particular thing at your home also. If suppose you are explaining for number of hours, but at the end of the day he is not responding at all. If you ask him whether you understood what I explained you, and if he after putting a lot of efforts on the basically what he is giving the reply that uh, maybe he is not giving you any reply, then what you will think? Whatever the thought process is coming right now, the same thought process will be basically coming in my mind also. Sometimes I used to think that whether I need to tell you this method or not. That will be again a very different. Let me just go with the basically what that conventional method is, right? But believe me, if you not be basically throwing some challenge to the particular method, you are strict to basically you are totally strictly prohibited yourself to do this particular problem by the same method, then definitely in gate exam there will be twist and turn, and if there is a twist and turn, definitely you will be struggle, right? So that is what advantage of knowing many methods. Of course, I'm not saying that you have to be do the PhD in all the particular chapters of this system, no. But whenever it is required, try to stick with the whatever the concept is there and the method. In the Castiglione's method, theorem, the derivation of the strain energy with respect to the load, right? We already seen this theorem. Whenever the load is there, you try to differentiate, you will be getting the deflection at that particular load. If the load is there at the basically what? If I want to find the deflection at ith locations, I need to differentiate total strain energy with respect to the load at that ith location only. If there is a movement, if I need to find the slope at any particular point, you try to differentiate with respect to movement at that particular locations. If not, if there is no movement, you try to apply the virtual movement, and at the end of the day, you have to equate to zero. Please note down this two particular statement, two statement, very very important. Let me give an example, very important example, or we can solve this particular example in the next slide. That will be the better one. Now uses application is very very important for all this structural problem. For all this structural problem, this method is quite easy. This particular method is quite easy, my dear friend. And remember, guys, start making the short notes immediately. That is a very very important for all the subjects. Suppose mathematics is there, linear algebra is there. For that, you try to either you make the short notes or you just take the short notes of some topper, or some from somewhere else. But you try to stick with your basically what short notes like anything. Don't try to revise with the full notes. No, it will take some time. All the good points, all the some good numericals has to be there in these particular short notes, so that you can revise within one day. On the next day, you can solve the problem. 2 day will be enough for solving the one particular topic. Next particular day, whatever the calculus is there, then Laplace transformations, whatever the topic you might be having in aerospace, you can follow and you can get the answers. Means that is a method of revision actually. And remember, if you are revising and doing the practice in the test series, if you continuously repeating these two tasks, revision plus test series, definitely you will achieve some good rank automatically. That is the psychology of the mind, and that is what the psychology of the gate exam. That's it. No need to get panic whether you are remembering the formula or not. But on the day of gate exam, all the formula you will remember like anything when you just revise at least 5 times that particular subjects. Not 5 times, need not to be 5 times. It can be 2 to 3 times, but at least 2 times has to be the revision should be there for a particular topic, for a particular formula. How you can test yourself, you can write sigma and theta without seeing the particular notebook. After the class, what you do, you just write the formula, whether you are remembering the formula or not, that principal stress or maybe the stress on any particular plane, whether you are remembering the formula correctly or not. Definitely, if you're not remembering, you will be getting doubt whether it is a sine theta or cos theta here, something like this. If you don't remember, you will be having the confusion whether it is a sine theta here, cos theta here. You will intermix. That you can verify, after basically whether you are knowing the remembering the formula or not. take one page, and try to note down all the formulas without seeing. And after 1 hour or 2 hours, just verify from the notes whether you have written the correct formula or not. If you are noting down the correct formula, that means you are remembering each and everything, and you are going on the wrong, basically what, right directions. And if suppose out of 10 formulas, 5 formulas are wrong, then you are learning, you are attending the classes regularly, that is a good thing. But mistake, there's a no scope of mistake in gate exam. Literally, there is a no scope of that, right? So now let me solve this particular problem. Why I'm telling you this thing, see, you might be basically learning so many things from all the other faculty, but believe me, these things are very, very important, right? Not only example, a cantilever beam which is being subjected to a point load P, we need to find what is the deflection at B point. Same problem I'm taking my different, right? And which is having a length L, which is having a length L. Here, my dear friend, I need to find what is the deflection by using the Castiglione's theorem. First of all, find the moment. What is the bending moment which are happening at a distance xx, particular section what? Mxx will be what? Minus p into x. That is the bending moment which is be applied. My dear friend, what is the strain energy we can find? Mxx whole square dx divided by 2ei. We are moving from 0 to L. Then what is the u value? Minus p into x whole square dx divided by 2ei. Then what is the u? P square divided by 2ei. Integration of x square. Integration of x square will be what? 2ei x square dx from 0 to L. X2 divided by 3, that I am putting from 0 to L. So what I am getting? P square L cube divided by 6ei. And now I need to find my different, what is the deflection? By Castiglione's, if I need to find the deflection, I need to differentiate total strain energy with respect to the load, which is being applied at what? Which is being applied at B point. And what is the load which is being applied at B point? What is the force P? Force B, P only. So dou by dou P of P square L cube divided by what? 6ei. So ultimately what we are getting, my different? PL cube divided by 3i. Make a note of it, very, very important. And that is what you got the same answer, a cantilever beam which is being subjected to free end load, PLQ divided by 3i. That is what the known formula for basically what is standard case. Is it done for all? Now, my different try understanding what I'm just saying. Just wait, I need to add this slide. See, here we can make use of same problem, but how to find this slope. If somebody will be asking you how to find this particular slope, you can make the use of strain energy, again same case. at A point, B point, we need to find the what is the slope value at B point. Suppose, for example, if somebody will be asking you what is the slope, previous problem is fixed beam. For that, it will be a very lengthy actually, because in the in the fixed beam, what you can have, you don't know the reaction value. What actually we need to find, you need to find the what you need to find with the help of strain energy method. You need to find the reaction value, for example, or reaction moment. So you can make use of this thing. You can do, what you can make, you can just take total strain energy with respect to the load or moment, or whatever the reaction forces there are, whatever the reaction force is there, with respect to that reaction force, you can take, and at the C point, at the B point, and you can equate to zero, because deflection at B point ultimately zero. So whatever the total strain energy, if you are able to find total strain energy for this fixed beam, then you can differentiate with respect to R, because load is applied what R there, and that equate then that particular point you can equate to what, zero. So ultimately you will be getting one equation. If you are finding the strain energy in terms of movement, you will be getting some equation. That equation just equate to zero. Definitely you're gonna get some value. You know, for that you need to calculate the movement at any particular section, right? The movement will be what? R into X minus what? M. Getting my point? But we need to take care of one thing. Whatever the differentiation is there, that differentiation load should be unique. That should not be applied somewhere else. But you can see that this R has been applied here also. This R has been applied here also. So definitely we have to apply some kind of virtual load, P. So with respect to P, you have to differentiate and equate to zero. So again, that will be very lengthy. You can try. You can try after learning the strain energy method. You can try this, and you can get the answer whether you're getting M is equal to PL by 8 or not. And let me know in the WhatsApp whether you're getting or not. Right? Understanding? You can do that. You can do. There is a, see, every method can be applied to every problem, but it is the task whether you are able to complete that particular task by some step or very large step you are required, right? For example, here a very simple problem we can solve by moment area method, but unnecessarily if you are solving the problem theta b, unnecessarily we are making lengthy one. Why? Because we need to find total strain energy, and we can equate to bending moment which is being applied at B point, that is equal to the value of theta b. But here there is a no moment. We have to apply some virtual moment. We have to apply some virtual moment. And that virtual moment we have to equate to what? Zero. That particular virtual moment we have to equate to zero. Let's see. Let's see, my dear friend. What is the bending moment which is being there? Now you calculate the total bending moment at any particular distance minus P into X minus M. That is what is the bending moment. Now, what is the strain energy, my dear friend? What is the strain energy? Strain energy, we know that mx square dx divided by 2ei from 0 to L. Now, if I differentiate with respect to M, what I'm going to get, my dear friend? 2 mx dou u by, dou u by dou M. So, what I'll be getting? Here, if I just do, I'm just telling you the shortcut method. No, just wait. Directly we can do. See, so we got to know that whatever the bending moment is there. Now we find the total strain energy minus px minus m. Now somebody might not be interested in that in this particular method, but believe me, any structural problem will be asked that can be solved only by this method very comfortably, right? Other methods will take lot of amount of time. Let me show that particular question. Let me show the motivation, let me give you some motivation. See this particular problem. See this particular problem. If they will be asking you, you just solve by the all the method, movement area method and all. Whole 180 minute will be gone in that particular method only in GATE exam. So definitely we have the motivation. What is the motivation? We can solve this structural problem very comfortably by this particular method, right? Now we got the motivation. Now we can work on. Now see why I believe in the motivation is that suppose in the early morning you decided that today I will be finishing my task within 8 hours. And why I will be finishing? Because I need to, maybe I need to enjoy after 8 hours, or maybe I need to just complete my goal. At the end of the day, I need to get the good rank in the GATE exam. Then only you'll be working for 8 hours, my different. Otherwise, simply not at all. You definitely not gonna work. In the next morning, if I after listening lot many motivations, whatever the motivational speaker is there on the YouTube, on the next day, definitely no motivation will be there. Everything will be gone. So you have to motivate yourself by giving some motivation goal. What is that? I need to get the good rank. Then only, suppose you are waking up in the next morning, maybe the day will be what, 10th of the November, and you will be thinking that I need to finish my, suppose that gas dynamics like anything, or fluid mechanics like anything. Within 8 hours, I need to revise completely. By hook or crook, you have to solve it, and you have to get the basically reason of all the fluid mechanics and gas dynamics. Then only you will be doing that. And if you're not talking to yourself that I will be doing or not, let me chill out. If I'm not able to finish today, let me try. Maybe within 3 to 4 days, I will see that whether I'm able to finish or not. Definitely, if you keep on postponing, automatically things will be getting postponed. Right? So that's why I believe that I used to follow this method like anything, and it worked like anything. Right? Now, a plus b whole square, what we can make? P square x square plus m square plus 2px m divided by 2ei, and we have to do dx from 0 to L. So what we can make? U total. So we can make integration of p square divided by 2ei x cube divided by 3, that is the integration of the first particular term, plus m square divided by 2ei. Again we are doing integration. No need to do the integration also, my dear friend, because m we have to keep it 0 at the end of the day. But let me just keep it right now because we are finding the total strain energy. So the total strain energy will be P square divided by 6ei L cube plus m square L divided by 2ei plus Pm L square divided by 2ei. And my dear friend, we have to do the differentiation of dou u by dou with respect to m. This will be gone. This will be what? 2ml divided by what? 2ei plus Pl square divided by what? 2ei. But we have to keep it m is equal to 0. This will be gone. Ultimately, what is the dou u total divided by dou m we are getting, my difference? That is the slope at b point. That is equal to what? Pl square divided by 2ei. Check it out whether you're getting the same or not. At the end of the day, we have to do virtual movement that is equated to what? 0. But after differentiation, don't keep it 0 here itself. If you just keep it 0 itself here, gone. Right? For that particular, only mantra is there to get, basically practice and practice and practice. After practicing so many times, you will be mastering that. You will not be able to believe that how I mastered this particular diffraction chapter like anything, or this particular chapter, But believe me, with the practice, everything will work out. Just believe me. Just believe on my words definitely you will come to know maybe in the month of January that you are started getting the feeling of solving the problem by a specific method for a specific problem. But you have to work hard for that. Automatically, nobody can give you the some basically direct tips that for this particular problem this will be applicable, for this particular problem this will be applicable. Now simply if I just throw one question, can I throw one question right now to test that whether we are understanding or not? Let me just throw one question, a very simple problem, try understanding. Example, or you can solve this particular problem as a homework also. See, a very simple problem, it looks very easy and it will basically make you tempt. Basically it will try to give some unnecessarily false, basically what we can say the fruitful kind of thinking, that false thinking. It will give this particular problem that you can solve this particular problem by movement area method. Let me show that. This is ei, this is 2ei, and we have solved one problem also, cantilever. But let me just convert this into simply support it, but with the point load that is symmetric point load. I'm not changing the load, I'm exactly putting the load exactly at the middle, L by 2, L by 2, exactly at L by 2 distance. Basically I'm putting the load, so it is basically seems like the case of something like this, and we can solve the problem very comfortably this by movement area method. What I'm asking, deflection at C point. So anyone in the class, they can just tell me, sir, deflection at C point is maximum. Here slope is 0. Here slope is maximum. So I can solve it very comfortably by the movement area method. I can draw this slope from here, and basically the distance from here to here, that will be deflection C with respect to A. And definitely this will be theta A. So sir, I need to find deflection at C point. So that will be theta A into L by 2. That is the total distance. I need to subtract theta C with respect to A. You can get the answer very comfortably. And what is the answer also? Standard case, PLQ divided by 40 ATI. Everybody know that. But with a little bit changes in the question, sorry, in this question, my friend, there was constant EI. This is EI, this is EI. Both the segment A, C, B are having the constant value of EI, but here I change the value EI to 2EI. If I change the values of flexural rigidity, by dear friend, you try your head like anything, you will not be getting the answer by movement area method. Until unless you are very conceptual about the radius of curvature. Here in this one, the radius of curvature will be, or elastic curve will be something like this. Here you will not be getting the maximum deflection here, you will be getting deflection somewhere else. And at the point of maximum deflection, only slope will be 0. It is not the C point, it may be D point. Then gone. Then it is gone. If you are knowing the zero slope value, then it is very comfortable to solve that one, because we can very easily solve theta A. We need to find theta A. How we can find theta A minus theta C? Area of M by EI diagram between A and C. Theta C no 0, theta A can be find out. But the moment we don't know the theta C value, once we have theta C, here theta C is not equal to 0. Once we have that particular value, everything is gone. So for this type of problem, you are welcome to solve this problem by what? Strain energy method. Of course, very lengthy, but you can solve this particular problem by strain energy method. How you'll come to know? Any mantra is there? Any some kind of prasadam is there? Nothing. It is just coming because of the practice. When you have the hell lot of practice, then all you can come to know how the elastic curve will be behaving, how the elastic curve can be made for this particular diagram. And some of you might be thinking, sir, why the elastic curve is something different for A to C and C to B? Why it is something like that? Again, if you are not following the classes, then definitely you're gonna miss. R is equal to what? EI by M. For this particular part, the radius of curvature will be, suppose R1. For this particular part, the radius of curvature will be R2. If it is symmetric loading condition, my friend, if it is symmetric, then the radius of curvature will be same. Then only the symmetric and deflection will be 0. Slope will be 0 at the C point. But here, my friend, R1 is what? EI. And what is the R2? 2 EI by M. Definitely R2 is more than R1. If the radius of curvature is different, how the hell can you get that symmetric loading condition over here? And because of that elastic curve, we will be getting deflection at somewhere else, not at the C point to be 0. And if theta A is there, suppose to find theta A itself is different, it is very difficult task, then how can you find deflection at C point? With the folded hands, we will say that we can solve this particular problem by Castigliono's method, right? With the same particularly success what we are getting in the deflection chapter, with the same success rate we have to work on each and every what subject. Then only you can crack the every question in GATE exam. No question is very tough. No question, basically they are basically framing the question from the NASA. Every question is you might have seen in the textbook, you might have read before, but it is not just clicking at the day of GATE exam. Why it is not clicking? Because of lack of practice. It is a very big word. Right? So you can solve this particular problem and let me know the answer, whether you are getting the answer or not, right? Now you just note down and let me know once it is finished. If they want to throw the difficult question, 2 marks, they can just throw that question, simply problem. But in the cantilever, there's no difficulty. Even in the cantilever, if I change the loading condition like this, EI and 2EI, nothing matters, because at the day end, the slope is 0. And we are taking the reference from here. Happily, we can solve deflection at anywhere. Cantilever, no difficulty. But the moment if I change the beam itself from cantilever to simply supported, everything will be changed, right? And if you just keep on noting down each and everything, sir, okay, this particular problem, this method, this problem, this method. Again, I'm telling you, this is not a UPSC exam. This is not a history exam of 10th standard. So that you can remember so many things and you can just proudly say that I can get the good rank. No. There is a lot of difference between UPSC remembering exam and aptitude exam. Right? Is it done, all of you? Can I move to the next segment? Let me show the beauty of this method. You earlier you might have learned this method or not, I don't care, but you try understanding this particular problem method. In previously in the aerospace, they might have asked is structural problem or not. It doesn't matter as of now, because you don't know, your parents don't know, or maybe faculty don't know, even institute doesn't know which question gonna come in next year GATE exam. Nobody can predict. If nobody can predict, then how can you easily predict that it is not going to come? Don't do that blunder for any subject. Do not take any topic very lightly, right? Now, because I have seen that some of the toppers who struggle in strength of material like anything, just because of the lack of practice, or maybe the feeding from the institute is not that much good. The feeling itself is made that this subject itself is very difficult. It is difficult for everyone. No. Who said that? That is a false assumptions, right? Now let's solve this particular problem. How we can just proceed with this one? There is a cantilever beam with some kind of structural loading case. Let me just take OA, B, C. Now, my dear friend, we can solve this particular problem by two manners. We can find the total strain energy of the beam, and then we can equate to 0. At the total net deflection at A has to be 0, then total partial differentiation of strain energy with respect to the load at the A point, that has to be 0. We can solve with that with respect to that method, or we can solve this particular problem by principle of superposition method. How? It's very simple. What will be the value of x? What will be the value of x so that the displacement at A will be 0? How we can proceed? See, try to shift the loading condition from D point to A point, and somebody told you how to shift the load. Apply two load which is equal in magnitude and opposite in directions, right? And there is a one kind of P is coming over here. So this P will create some kind of load. What is the equivalent diagram? Equivalent diagram will be one P will be coming over here at A point, one P will be coming over here, and this P will create the moment. Will create the moment something like this. And what is the moment? P into L minus X. What about this distance? This will be L minus X. Getting my point? So now when you try to solve this particular problem by principle of superpositions, we need to find what? Net deflection at A. Net deflection at A to be 0. That will be 0 by 2, 1. By this one also has to be 0. And by this one also it has to be 0. Sorry. This is the A point and there will be some movement. There is a some movement, right? What is the deflection because of P? Everyone know that. PLQ divided by 3I. Because of the cantilever, we have this standard case. And again, we have this standard case for this case also. Minus M L square divided by 2EI. That is equal to 0. So now just equate to that. PL by 2, PL by 3, that is equal to what? M. PL minus X into 1 divided by 2. P will cancel out. 2L is equal to what? 3 into L minus X. So 2L is what? 3 into L minus 3 into X. So 3X will be equal to what? L. So X by L will be what? 1 upon 3. So X will be what? 0.33 L. You can solve this particular problem by Castiglione's method also. But again, very lengthy one. Is it done? Once it is done, let me know. Now, by different try understanding the particular problem that I am giving you as a homework. I'm just giving you as a homework. Try to solve it. A beam ABC made up of two segments. The load has been applied at the C point as W. The length I'm considering L. My different a cantilever beam which is made up of two segments AB, BC. Again, EI is a flexible rigidity for both the beams are same AB, BC. Both the part of the same beam, different segment are there. What is the deflection at C? What is the deflection at C? You can try solving this particular problem by strain energy method. Note down the answer also. 4 by 3 PLQ divided by PI. You try it by what? Strain energy. Find total strain energy and just equate dou U by dou T divided by what? Dou U by W. That will be the answer. Total strain energy will be what? It will be BC plus AB. BC you can able to find by taking this section, but AB is very, very important. This is very important. Try it. If not, I will be solving. Make a note of it. All this particular problem, you can just solve it. See, the same problem they have asked in your paper only, I think GATE 2021 in aerospace, they have asked same problem. But what they have asked, here they are asking the fixed support reactions, RA and RB. In your paper, they have asked what is the compressive load which is being applied at C. That means the reaction at C. So again, you might have solved this particular problem from the Hibbeler, definitely gate 21 problem was a very easy task for us, getting my point. I think yes, correct. Because what you can do, you can just treat it like this is P, so there will be some kind of R here, also there will be R. Once again we're gonna have this P. So how we can solve this? We can solve this by equating deflection at C point, to be equal, right? From this case and from this case, the net deflection at the downward direction will be zero, will be same, right? Deflection at A because of the one at C, deflection at C because of the two loading, second beam will be same way you did. Yes or no? Correct. You can verify all this answer, by the latest edition of the textbook Hibler I have uploaded in the drive itself. You can just see that, and in the bottom of the, basically in the below of all these chapter, there will be answer, so you can verify. 12.128, what is the answer, kind of things. Now, can I move to the next chapter? This is done for all. We have to start the bending stress, then we'll be proceeding towards the shear stress, then column, theories of failure, then we're gonna discuss thin cylinder. What? Which one? Note on the next chapter. Bending stress. In the bending stress, my dear friend, just note down the pure bending and non-uniform bending. Just note down the diagram first of all. From here, let me just take this thing. Correct. Note down from here to here also. Sorry, from here to here, very very important. Yeah, yeah, correct, correct. What are the answers you're getting? You can solve that particular problem, by this one. We need to find the reaction force at B point, something like that. So if you are getting the deflection because of WL power 4 divided by ATI, if it is exceeding this particular gap, if it is more than 6 mm, then the reaction at B will not be equal to 0. I think 75 is correct. Correct, I think. Once again, I will check that, but I think so. That is correct. 75, what you are getting. Now, note on the pure bending. Pure bending means there will not be any safe force. There will not be any, there will not be any. Correct. 75 Newton will be correct. Good. A pure bending means, note down, a pure bending means shear force will be 0, bending moment will be constant, shear force will be 0, axial load will be 0, twisting load will be 0. Anyway, twisting load will be 0. As of now, we are not discussing any twisting. Bending moment is constant, but that is not equal to 0. So this is the condition for pure bending. Condition for pure bending. Non-uniform bending means bending moment will not be equal to 0, but that is not constant. There may be some shear force, There may be some other, axial load kind of things. So this particular example is a pure bending example. As you can see, there is a no shear force. No shear force. If calculate the reaction RA and RB, you will be getting 0. RA and RB will be equal and they will be 0. There's a no vertical force. If there's a no vertical force, 0. No shear force diagram will be there. So bending moment will be constant. You know, pure bending refers to the flexural. Flexural means bending. Pure bending refers to flexural of a beam under the constant bending moment. Therefore, the pure bending occurs only in the region of the beam where the shear force is exactly equal to 0. Is it done? All of you have noted down? Let me give the example of non-uniform bending also. Done? All of you have noted down? Now, not on the next case, in contrast, in opposite of what we have discussed regarding the uniform bending, non-uniform bending refers to the bending in the presence of shear force. That means if I give an example of a simply supported beam which is being subjected to load like this, right? Now, in this, if you draw the bending moment diagram, it will be like this. L, 2L, L. So this is what the region we have A to B and B to C, C to D. So A to B, whatever the reason we have A to B and C to D, these are the non-uniform bending, These are the non-uniform bending, my dear friend. You observe very carefully. These are the non-uniform bending. Or I can just make this figure over here. These are the non-uniform bending. So AB and CD are the non-uniform bending. Because shear force is present. Why the shear force is present? Because if you draw the shear force diagram, you will be getting the shear force diagram something like this. W, W, W minus W minus W. Between A to B, B to C, C to D. Between B to C, there is a no shear force. That's why you have the constant and maximum bending moment. So B to C will be called as uniform bending. Very important, make a note of it. What is the benefit of uniform bending? The radius of curvature will be constant. EI by M. If M will be constant, the radius of curvature will also be constant. It will become a circle. It will become a circle. Now let's discuss some of the beautiful concept of bending stress. Done. Is it done for all? Is it done? All of you note it down. Tell me, guys. Correct. So, my dear friend, we have to discuss about the longitudinal strain. Note down this particular topic: longitudinal strain in the beams. You can make this figure. This particular beam is being subjected to a movement, right? This particular beam is subjected to a movement, and we have to basically tell what will be the longitudinal strain. What will be the longitudinal strain? So for this case, I'm taking one simple example. This is the beam which is having the. I'll be telling you the meaning of neutral axis and the neutral surface. As of now, you can consider this is a neutral axis, for example, and it is passing through the centroid. You can consider two section which is being applied. Suppose there is a hogging bending moment, and I'm just taking for section. This section I'm taking. Let's suppose, for example, I'm taking A point here, B point here. This will be the EF. This will be my C dash and D dash, and I'll be taking my fiber. I'm taking a small fiber CD. If I zoom it out, I'm taking one small fiber CD at a distance y from the neutral axis. Right? Make a note of it. If it is bent, it will bend in the form of arc. Definitely, it will bend in the form of arc. You just focus your attention, my dear friend. You just focus your attention on this part of the beam. The top fiber EF will be compressed. Will be what? Elongated, and the bottom one will be what? It will be compressed. But there is a one layer where there is a no compression, there is a no extension will happen. That is a neutral axis, a neutral surface, rather to say, it is a neutral surface. And this particular hatched portion or the fiber, it will be y at a distance y from the neutral axis. For example, I'm taking the radius of curvature from here to here. This is my radius of curvature. For example, this is my radius of curvature, which is subtended an angle, something like this. Why I am able to make this circle? Because bending moment is constant. The radius of curvature will be constant. R is what? Radius of curvature. The radius of curvature. I need to find what will be the longitudinal strain for the fiber C dash and D dash. Sorry. I need to find the what will be the longitudinal strain for C1 dash and D1 dash, because C dash and D dash we have already considered this one. So after bending, my different, what will be happening? The normal strain. Everybody know that the normal strain. The normal strain for CD layer will be, the normal strain for CD layer will be, what it will be? It will be C double dash and D double dash, because C dash and D dash already have been considered. And everybody know that what is the normal strain on the fiber CD? The change in CD value divided by original CD value. So what we can write, C1 dash D1 dash minus CD divided by CD. What is the C1 D1 dash? What is the C1 dash and D1 dash? What we can write, my different? Can we write this is a Y? So can we write C1 dash D1 dash as R plus Y into theta? And can we write CD value as R theta? Check it out. Why we are able to write CD as r theta? Anyone know that? Why we are able to write CD as r theta? See, look at here, from here. What is the AB? AB, you know that this will be the AB value. Before AB, before bending, AB was equal to what? CD. So from here, what is the AB value? AB value is what? R into theta. When AB is r theta, then automatically CD will also be what? R plus theta, R into theta. So ultimately, what is the normal strain? The normal strain would be R plus Y into theta minus R theta divided by R theta. So when you just write, you will be finding what? Y divided by R. That is what my longitudinal strain. And I told you why we are calling this to be longitudinal. Along the beam axis, whatever the axis will be there, that is the longitudinal axis. Whatever the axis passing through the cross section, that will be centroidal axis or principal axis. Make a note of it. Don't look at CD from the after bending. After bending, there is no CD. CD has been converted to C1 dash D1 dash. And that is what we have found it out from the particular formula of circle. So from here, my different, what is the conclusion you are getting? The conclusion you are getting, the normal strain is directly proportional to Y. For a fixed radius of curvature, the normal strain is directly proportional to Y. So whatever the strain is there on the top fiber, on the bottom fiber, they will be linear with respect to what? Neutral axis. The line will be straight line. The curvature will be straight one in between that. Once it is done, let me know. See guys, if you don't want derivation, I can happy to tell you we are deriving the formula m by ei. M by I is equal to sigma by y is equal to E by R. If you just don't want any trouble, I'll be directly writing the formula. We will be solving the formula. Happily, we can conclude the session. But if I do so, in GATE exam, if anything can be asked on radius of curvature, and if they are connecting the dot between radius of curvature and bending stress, believe me, you try your head like anything, but you will not be able to solve. Until unless you know what is the meaning of radius of curvature, from where it is taken, how it is being developed, right? Until unless you know these particular fundamental things, you cannot be able to solve. Until you are superhuman, who doesn't know anything about the derivation, but he is able to solve, he or she able to solve the problem in GATE exam. But that happens rarely, with only hardly out of 10,000 or 20,000 students. Maybe it will happen with the one or two students. That's it. Remember, all the toppers, they don't basically they are topper. Of course they are topper, but it is not like that. There's a lot of difference between topper and you. No, they are the topper. Before topper also, they basically struggle like anything to clear about each and every concept. So don't think that God has given some beautiful gift in terms of concept to all the toppers. Nothing like that. All are the false assumptions, right? Why I'm telling, because these are the basically assumptions that is being spreaded in all over the across the India like anything. Now, is it done, all of you? Now, as you can see, what I'm telling, because why I'm just telling you, even though this was the before deformation, before bending deformation, after bending deformation also, these lines are straight one. These lines are the straight one. These lines are not a curvature one like this. No. Why? Because strain is directly proportional to y. Not believing? Check it out. I'm just telling you once again. See, this is a proof, what we are getting. I will come to this particular point. Let me show one point, very, very important. Let me write that. Now note down what I'm just telling you. This there was a basically the this particular part of the beam which is being subjected to bending. The bending has been something like this. For example, sagging bending moment has been applied. Because of the sagging bending moment, the top fiber will be compressed and the bottom fiber will be elongated. But how the compression and elongation will happen, that will be decided by one line. That is a, for example, this is the neutral axis. We know that after bending, it will bend like this. We know that after bending, it's gonna bend like this. After bending, this gonna bend something like this. One layer you can observe very carefully, the red color one. These are the neutral axis. After bending also, there is a no deformation on one particular axis, one particular surface. That surface will be called neutral surface, right? But what I want to show you from this diagram, this particular, deformations, this particular deformations, this particular deformations, this particular deformations, these are the linear one. See, these deformations will be linear one, my dear friend. These are not the curvature. Why? Strain is directly proportional to y. Getting my point? So if somebody will be asking you, draw the strain variation, draw the strain variation over the length, then what will be the strain variations? It will be something like this. Maximum strain at the top, maximum strain at the top. At the neutral axis, the strain will be zero. Right? And how it is varying? It is varying linearly. I have drawn the graph by the linear line, as you can see, linear variations. Y is the distance from the neutral axis. The distance of fiber or layer from neutral axis. Linear variation of longitudinal strain. Make a note of it. Very important. What is the neutral axis? It is the axis of intersection of. It is the axis of intersection of. It is the axis of intersection of neutral surface with the given cross sections. With the given cross section. With the particular given cross section, we can have the neutral axis. If I want to show you, let me show that. So that you can get the feeling of bending actually. Why I am saying neutral axis, neutral surface will not bend, will not stretch. Let me show by one important diagram so that you can just make a note of. This is the beam 3D figure I'm making. This is the beam actually, right? After bending, it is gonna be happening with this particular beam, something like this. After bending, perfect. So this is the top fiber. Whatever the top is there, top fiber. Whatever the bottom is there, that is nothing but bottom fiber. But there is a one surface apart from top surface and the bottom surface, but there is a one surface which is neutral, my dear friend. Let me show that, which is a neutral one. It will take some time. There's a one surface which is a neutral one. Try to imagine the 3D figure. You please try to imagine this particular surface. This particular surface, my dear friend, will be called neutral surface. Neutral surface. And what I was talking about, the neutral axis, it is the axis of intersection of the neutral surface. It is the axis of intersection of the neutral surface with the given cross section. With the given cross section, this is my cross section. This is my cross section, With this cross section, this particular neutral surface where it is coinciding, this will be neutral axis. This will be my neutral axis. Neutral axis can never be seen in the plane of beam. It can be seen in the plane of cross sections. Make a note of it. If I'll be asking you how many neutral surfaces is there? One. How many neutral surfaces is there? One. How many neutral axis is there? What will be the answer? What is the meaning of neutral surface? Neutral surface will be called as where the net axial displacement will be zero. Where the net axial deflections or displacement will be zero. There will be only one neutral surface. But how many neutral axes? How many neutral axes, my different? See, you can have the plane of cross section over here also, You can have the plane of cross section over here also. Something like this. So once again, it will be what? This will be the neutral axis. Once again, here also there might be neutral axis. So there will be some infinite neutral axis. But there is only one neutral surface. We don't have cross section at the here and here, at the extreme left and extreme right. In the middle also, in between the middle and extreme right hand, in the middle of extreme left and middle and middle one, many are there. Many cross section will be there. Infinite cross section, infinite neutral axis. Make a note of it. Sigma will be zero, epsilon will be zero. No, why epsilon is zero? We know that because there is no bending deformations. But why strain is zero? Because of the Hooke's law. Every material in the strength of material, either twisting chapter or bending chapter or axial chapter, always it will follow the Hooke's law. The strain will be directly proportional to strain. If strain will be zero, stress automatically will be zero on that particular surface or layer. Make a note of it. So longitudinal strain longitudinal strain directly proportional to y. These are the important thing, guys. This time we have the MSQ. Lot many MSQ will come. MSQ will decide your rank. In MSQ doesn't mean that the numerical will be asked. They will be asking you so many theoretical questions. A good theoretical question based on the derivations, based on the each and every concept. Who knows that they will be asking this particular question? A particular beam which is being subjected to uniform bending, it can be subjected to bending. How many neutral axis, how many neutral surface will be there? They can give the options. Now, all of you done? All of you have noted down? Can I move to the next segment? Done? Very quickly. Is it done? Try understanding, my dear friend, the next segment which I am just talking about, according to Hooke's law. I think it is given in the slide, so let me check it out. See, for most of the material, it follows linear elastic material, right? For a linear elastic material, according to Hooke's law, stress will be directly proportional to strain. And strain, we already seen that. Strain, we already seen that y by r. So what we can write? According to Hooke's law, stress will be directly proportional to strain. So E times of what? Epsilon x. So stress will be what? E into y by r. So one equation we got, sigma by y is equal to E by r. One part of the equation has been derived. One part is remains, that is m by I, right? This is the first equation. Now don't worry about the minus sign, because they might have considered in this particular question, let me see. Okay, so initially you might have seen the bending. They might have applied the, let me check it out, why they have written minus. See, in this one they have considered the strain AB member, you know for basically above the neutral surface they have considered the layer. And for above surface, my dear friend, automatically anybody in the class, they can tell me the final length will be lesser one as compared to initial length. So definitely strain will be linear one. Sorry, that will be minus one. That's why they have kept the minus sign. Do not worry. We have considered why we are getting the positive signs, because we have considered our section above the neutral surface, but in the sagging bending moment, kind of things like this. This one layer we have considered, above the neutral axis, neutral surface. That is the positive. Below neutral surface, all the things will be negative. Bending stress, longitudinal strain. Above neutral surface, everything will be positive. Right? So from here, what we are getting by different? Bending stress will be, this is the bending stress. You are welcome to the what? Bending stress. Bending stress will be linear one. So in GATE exam, we got one question, GATE 2023. They have given one question, the beam is subjected to a bending moment, and they have asked that four options they have given. The strain will be linear one, something like this. B option, C option kind of like this, D option kind of something like this. They have mentioned that strain is linear, stress is linear, strain is something like this, stress is something like this. Four options they have given. Which option is correct? Only one is correct. MCQ is there. If I'll be asking you the same problem, one particular option they have given, strain is linear. Second option, stress is linear. Third option, strain is parabolic. Fourth option, stress is a uniform distribution, just like axial loading case. And this particular problem is for 2 marks, for example. Then what you gonna say me? I don't know about the other student, but if you are the strength of material students of mine, definitely very hardly any chance of doing the mistake. If you follow my initial classes, then definitely no chance of committing the mistake in the GATE exam. Who come first? I asked one question in the strength of material, who come first? Stress or strain? And all of you suddenly told me that strain. And if strain first come, then automatically A will be correct, By the Hooke's law, after development of the subject only, Robert Hooks, who developed this particular subject, he got to know that, okay, stress will also be proportional to what? Strain. But strain first come. If the strain will be coming first, then definitely in that strain will be linear one. It is not that B is incorrect, but if there is only one option has to be ticked out, then definitely strain will be linear one. Automatically stress will be linear one, right? That is what the aptitude that has to be used, right? It is not the development or history of the GATE exam, or basically the strength of material that is strain come first. It is not like that. It is there from the graph also. We are plotting the graph, stress versus strain diagram. Why we are plotting strain in the X diagram? That is what they have tested in the GATE exam. That's it. Ultimate motto of IIT professor, they want to test whether you know this thing or not. They just frame the question in the form of 2 marks. That's it. Basic and aptitude will fetch you a good rank. If anything is missing, then definitely a poor rank will be there. Now make a note of it. I think all of you might be noting down. Is it done for all? So that we can derive further, because second part is left out. M by I is equal to sigma by y is equal to E by R. So we need to prove that how we are getting M by I actually. So now my dear friend, just make a note of it. The next particular segment, very important. So we have seen that bending of the beam. If I make 3D figure of this, this is what we have: the neutral surface, neutral axis. About the neutral axis, my dear friend, I have considered one segment, right? On that segment, I'm considering one small area over which the force has been applied, df. Df is a force which is being generated. Everybody know that. And let me just take the distance from here to here will be y. From this particular axis to this one, the distance is what? Y. My different what I can write from this one. Everybody know what is the bending stress? E into epsilon, E into y by r. Everybody know that, right? This thing everybody know that. Just now we have proved. So I'm considering one layer which are there at a distance y from the neutral axis, my dear friend, and which is being applied df force. Now you take the moment. What is the dm moment about this particular element? If I integrate, I'll be getting the whole moment, of this particular force. So what is the moment? Df into y. Just try to imagine. Df into y will create the moment like this. T. Either you can write the moment like this, or we can write equivalent diagram, something like this. P and P. We'll apply the moment like this. Equivalent diagram kind of things. So what we can write, my dear friend? M will be equal to df. What is the df? What is the df? Sigma is equal to force divided by area. Then df will be what? Sigma into dA. So I can write sigma into dA into y. Sigma I am taking outside, my dear friend. Sigma I am taking outside. Or further, what we can write? I can just write sigma in terms of Ey by r. Ey by r from this particular equation. Y into dA. And my dear friend, what we can write? M will be what? E by r, that is a constant, that will be coming outside of the integrations. And from the engineering mechanics, anyone can in the class can tell me what is the y square into dA? What is the y square into dA? I about the neutral axis. M by I neutral axis, that is equal to what? E by r. And E by r we know that sigma b by y. And that is what you are welcome to the bending equations. That is a proof. Make a note of it. You need to revise moment of inertia. You need to revise center of gravity, guys. I can give you a little bit idea about that, but not completely. So we got the equation m by I is equal to sigma by y is equal to what? E by r. Just note down the what these terms are representing. What these particular terms are representing. Just make a note of it. Is it done? See, these are the perpendicular. Don't think that I cannot make actually. It's a 3D figure. Df into y. that will create the moment. See, proof is proof, guys. Derivation is derivation. Sometimes derivation will be tough. If you ask faculty of aerodynamics to do the derivation of each and everything, and if he keep on doing each and every derivations, you will feel bored in the class. Aerodynamics is such a beautiful subject, or maybe anything, aircraft performance or something else. If you ask faculty to do the derivation each and every topic, it will be finished in 6 months, one subject. And you will feel that after derivation also, sir, I feel that okay kind of things. Then what will happen? So of course we have to do the derivation, but not all. Remember that also, that also you need to keep in mind. For each and everything also, doing the derivation will be harmful for a get exam. Whenever it is necessary, whenever it is required, how we got the formula, what these terms are representing. That suppose r, if I would have been directly writing down this particular bending equation, you never come to know that r is from where to where, right? And why we are getting I is equal to what? Neutral axis. Why only neutral axis? Because we are taking the moment of inertia about the, see, y square into d is what? Second moment of area, no? Y into yda. So force into distance is a moment. We are taking the moment about axis. That axis is neutral axis. That's why I neutral axis is coming, not something else axis. We are not taking the moment of inertia about the bottom fiber or top fiber. Why neutral axis? Because of derivation. And you will come to know very soon, that neutral axis is coinciding with the centroidal axis of the particular cross section of the beam. Now, note down, whenever any cross section is there, there will be neutral axis, there will be any fiber at a distance y, then we will be having the bending, basically variations will be, for example, this is the bending moment like this. So there will be some variations. At the neutral axis, it will be 0. We're gonna have this variations, right? This is the bending stress variations. M by I, M is bending moment, on the cross section of beam. I is nothing but I about the neutral axis. Sigma B is the bending stress developed at a fiber. Located at a distance y. Y will be the distance of fiber on the plane of cross section, from its neutral axis. And R, everybody know that, radius of curvature. Note on, we can see the remaining thing in the next class about the bending stress as well as the numericals of the bending stress. Bending stress and the direct shear stress, we also call transverse shear stress, will be finished. Once it is done, we can leave for the day. Is it done for all? Okay, thank you all.